Okay, hello everyone, welcome to the new class. We will introduce a new section on the advanced indexing in this class. So we have finished the data storage and implementation in the previous section already, and we'll move to the new section in this class. And we plan to finish this advanced indexing this week, and also we will talk about this in the next week as well. We have also released the slides for the indexing section as shown here already, and you can also download the slides after class if you want to check the materials we have covered. As we all know, indexing plays a very important part in database system, especially in the query execution. So normally when we have a large scale database systems and we want to do some query based on the database system, one of the most important part will be given some inputs, some attributes, can we find some data tuples matching the inputs precisely. So this is also called selection or the search process, right? Normally, if the data set, the database system is small, then the search process will be very fast. However, when it comes to a very large scale database system, in Facebook, in Google, in Amazon, and Microsoft, if we want to do the search based on their internal database system, then this query execution time cost will be very high. The main reason is because if we want to match the input attributes with attributes of data tuples inside database systems, we probably need to scan over the whole data we have in the tables, right? If we have 1 billion or 10 billion records in the data tables, then the time cost will be very expensive. So therefore, to speed up the selection or the search process, we may need to introduce a data structure in database system, which is called indexing or the index tables. So for the index table, normally give the input search keys or attributes, the index table can provide us with pointers pointing to the concrete data tuples matching our input keys for the searching of the data tuples actually. In other words, given the inputs, we can generate or give a pointer pointing to the concrete data tuples matching the requirements, which can speed up the search process very fast. So I think we have all learned this indexing in the database system for the undergraduate program, right? So you can also check back your materials you have learned before for the indexing. Normally, to speed up the search process, we can build different kinds of indexes for the database system. Depending on the availability of the resources, the index tables can be organized in different ways. For example, we can organize the index table just as a sequence, and sometimes we want to maintain a sorted order of the sequence, right? And then we may need to have some requirements if we want to insert or delete some tuples or records from the index tables. As later on, we will have some new data structure proposed, like a B plus tree and a B tree. In other words, we can organize this index table into a tree structure diagram instead. So given the records we have in the database system, we can insert them into the B plus tree, this data structure, which can speed up the search process very fast. Normally for the B plus tree or B tree, given the inputs, we can search the data tuples or the pointer to the data tuples very fast from the root of the B plus trees. Then we search along the branches of the among the nodes, and until we reach the leaf nodes, we will be able to access the pointers right to the data tuples. So for the B plus tree, we have the pointers only at the leaf nodes, right? So for the internal nodes, we have this branch pointer pointing to the internal nodes. However, if we want to find the pointer pointing to the concrete data tuples, we have to reach the leaf nodes instead. In other words, for the B plus tree, the search time cost will be always ahead of the B plus tree, which will be about big O log n, right? And so another data structure which is very important is called B tree, right? So B tree further improves the B plus tree. In other words, for the B tree, we can also have the pointers pointing to the data tuples for the internal nodes as well, which can lower down the time cost greatly, especially for the data points we have made before in the internal search process. And besides tree structure diagrams, we can also have these hash tables, which will be based on hash function. Given the inputs, we can define a function to project the inputs to a concrete position of the tuples or the records matching our requirements in the hash tables. And also depending on how we organize these hash tables, we can also have different formats of the hash table, like a linear hash table as well as some other advanced hash tables for constructing the index table for us. So there are different ways to construct the indexing tables, like the sequential order, the list, the B tree, B plus tree, as well as the hash functions. And we will mention them briefly in the lectures. However, we will focus more on the advanced topics for the indexing in this section instead. Now, the reverted indexing as well as the quarter tree and the KD tree like that, and R tree as well. So we will mention this data structure in this section for you, so you can have a big picture about indexing tables in database system. Okay. So the indexing is also one of the key topic in database studies. So you can also check some research papers on this topic as well if you are interested. It is one of the main topics for constructing a database system, and we also have some new papers coming out in recent years by using the machine learning, deep learning to help construct an index table which can be adapted to according to the input data we have. So it will be also a very interesting topic and for future explorations if you like this topic. Okay, so let's come back to the slide and we can have a look at what is the index table we will cover in this section.